Afternoon, everyone. So this week we're going to be looking at the test memo. I'll be going through question 1, 2, and 3 with you guys. So assume that the total revenue of a firm is in main driven by its pricing strategy and its spending on advertising. The expected total revenue for the firm is given by the equation TR is equal to 5,000 minus 6P plus 4A plus PA minus 1.5A squared minus 0.5P squared. The constraint is P plus A is equal or less than 10. Determine or calculate the following. So the first thing that you're going to do is that you're going to compute your Lagrange function, which is going to be 5,000 minus 6P plus 4A plus PA minus 1.5A squared minus 0.5P squared plus mu times P plus A minus 10, close bracket. And then you're going to get partial derivatives of the Lagrange function in terms of your price and advertising and mu. So the first equation there, when we derive it in terms of P, this is what we get, minus 6 plus A minus P plus mu. And then when you derive it in terms of A, we're going to get 4 plus P minus 3A plus mu is equal to 0. And then derive the function in terms of mu, we're going to get P plus A minus 10A is equal to 0. So now I make use of elimination too. So we have three unknowns. We have three unknowns and we have three equations. So we can solve for the three unknowns with these three equations. So I made use of elimination, so it's going to be equation 1 minus equation 2, which will give you minus 10 plus 4a minus 2p is equal to 0. And then from equation 3, p is equal to 10 minus a. We can now substitute and take the your value for p from equation 3 and use it in the equation 1 minus 2, which will give you the following results: minus 10a plus 4a minus 2 times 10 minus a is equal to 0. Remember, we replaced the value of p with what we have here, with 10 minus a, which will give you minus 10 plus 4a minus 20 plus 2a. You solve it and then you're going to get 6a is equal to 30, which means that your a, divide both sides by 6, you're going to get a is equal to 5. And then remember, from equation 3, using these results, we're going to take this a, use it in equation 3, we're going to get 10 minus 5, which will give you 5. And then mu is equal to 6 for interest rate, but it is not needed for this question. So now to answer the question, the price is going to be equal to 5 and your advertising is equal to 5. Now, to get the expected total revenue, we're just going to substitute the values of P and A into our original total revenue function, which should give you 4,965. So when you substitute your values of P and A in the total revenue equation, remember this one, it should give you 4,965. Alright, moving on to the next question. Question 2. Question 2. Alright. Assume a profit function for the same firm. Profit is equal to minus 8 minus 4q plus 3q squared minus 0.2q cubed. Determine or calculate the following. Round off to 4 decimal points. So for this question, they asked you to get the minimum value and the maximum value. So to get the maximum and the minimum value of a function, we need to get the first derivative of that function. So when you derive this function, this is what you're going to get. It's going to be minus 4 plus 6q minus 0.6q squared and is equal to 0. Remember, when your first derivative is equal to 0, you know that your function is being maximized or minimized there. So this is what we get. Minus 0.6q squared plus 6q minus 4 is equal to 0. It's a quadratic for equation, so we can make use of the quadratic formula. Remember, quadratic formula, I've put it there, which is minus b plus or minus root of b squared minus 4ac the whole divided by 2a. So in this case, using the quadratic formula, These are your. This is gonna be your results. It's gonna be minus 6 plus or minus root of 6 squared minus 4 times minus 0,6 times minus 4, the whole divided by 2 times minus 0,6. You should get Q is equal to 0,7182, or Q, you should get two values of Q. Q is equal to 0,7182 and 9,2817. So now to check if whether which one is the maximum or the minimum value, you need to get the second derivative. So you use the second derivative to test your values there. So our second derivative is gonna be minus 1,2q plus 62. That's our second derivative. And then we're gonna plug in 0,712 into our second derivative and see what values we get. So when we plug in 0,712 into our second derivative, we get 5,138, which is positive. So that will mean this is our minimum value. And then when we plug in 9,2817 into a second derivative, we get minus 5,138, which means that it is our maximum value. So our minimum value is going to be 0,7182, and the maximum value is going to be 9,2817. So now let's look at question 3. A firm has two shops, one in Auckland Park and another in Honeydew. It costs the firm 10,000 per week to manage the shop in Auckland Park. 2,000 labor cost, 2,000 rent, 6,000 stock, and 14,250 per week to manage the shop in Honeydew. 3,750 labor cost, 6,000 rent, 4,500 stock. The cap for labor cost is 45,000. The cap for rent is 60,000, and the cap for stock is 90,000. Calculate or determine the following. Do not use the rand sign in your answer. So, okay, how you can go about this? Alright, first question is state the primal problem. So here, you're trying to minimize cost, right? So it's gonna be minimizing cost. And how much does it cost you to run Auckland Park? It's 10,000, so it's gonna be minimizing 10 AP. Sorry, 10,000 AP plus how much does it cost to run the shop in Honeydew? It's gonna be 14,250. Sorry, 14,250 H. Right, and then the second question is list the equation of the constraints. So how you can do this? I like drawing a table firstly. So we do this. You got Auckland Park, that's the AP, and then we have the shop in Honeydew. The different constraints that we have, we've got labor costs. I'll just labor, and then we also have rent, and then it is stock as well. Alright, the information that we were given is that to run Auckland Park it will cost 2,000 labor, so 2,000 for labor there, and then rent cost 2,000 for rent, and then stock is 6,000, so 6,000, and then it also adds up to 10,000, as you can see. For Honeydew, we've got 3,750 labor cost, 6,000 rent, and then what's this? 4,500 stock. Is that correct? Yes, 4,500 stock. And then the cap for labor cost is given to be 45,000. Right, that's your cap there. And then for rent it is 60,000. And then for stock it is 90,000. So now when we have the equations now, So the equations of the constraints are going to be for labor. Let me do this, sorry. 2000 AP. Remember it costs 2000 at Auckland Park plus 3500 for Honeydew. Alright, and then we have rent, sorry, 3500, which is equal to 45,000. That's the max that we have for labor, right? Remember, then rent is gonna be 2000 AP plus 6000 H, which is equal to 60,000. And then for stock is 6,000 AP plus 4,500 for Honeydew, which is kept at 90,000. Right. So these are your constraint equations. Now they ask you to indicate the possible solutions. So what you do here now, you're gonna use the equations, the constraint equations, and then you're gonna find out the. So now let's look at the next question. Indicate possible solutions. So now for this question, what you were supposed to do is that you make use of linear programming. I plotted them as following. So I used Auckland Park on my vertical axis, and then on my horizontal axis I had Honeydew there. So you should get a diagram that looks like this. And with the minimization problem, remember that it is every your feasible region is here. Anything that's just above these lines on the right is your feasible region. So your possible solutions are going to be 1, 2, 3, and 4. So now to get the coordinates for these points is that we're going to make use of the constraint equations, and then we know that it's a intercept, right? So for A it's going to be 0, 30 by making use of the rent constraint, and then for B, which is here, B is going to be 20, 0. Those are your coordinates there. And then for C is the intersection between labor and rent, so it's gonna be here. And then these are the coordinates that you get for labor and rent. And then D is the coordinates are gonna be the intersection of labor and stock. These are your coordinates here. So therefore our possible solutions are, let me do this combination. We say the first one is 0H plus 30 AP. And then the next one was 20H plus 0 AP. And then the third one is 6,67 H plus 10 AP. And then the last one minus 6,67h plus 10AP. Right, so these are the possible solutions, and then the values, when you substitute the 10,000, remember it costs 10,000 to run Auckland Park, and then it costs 14,250 to run Honeydew. So our solution here is going to be 30,000 30 times 10,000, which is equal to 300,000. And then the next solution is going to be 20 times 14,250, which is equal to 235,000. And then for this one, it's going to be 6,67 times 14,250 plus 10 times 10,000, which is equal to 195,000. So, 47.5. Okay, this is the same as well, same answer. So now the next question is, what is the best solution? We have two best solutions here. In this case, we have one best solution. It's the same thing, so it's gonna be 6,67 plus 10 AP. That is the best solution. Remember, we're trying to minimize costs. That's the problem. So this is the lowest cost that we have. So that's the best solution for this. I hope everything is clearer